morning, dear students. Today we are going to study the theory of wireless communication. So, this is we communicate with the help of advanced electronic devices. The main purpose of communication is to transfer the information. In olden days, people are using birds, animals, pigeons, etc. to transfer the information. When you transfer the information with the help of pigeons or animals or eagles, etc., the information may not reach the person in time, and it may not reach the exact person. So, when we use electronic devices, within fraction of second we can transfer the information, and moreover it will reach the right person in time. Now, the main purpose of communication is to transfer the information. Now, the communication refers to sending, processing and receiving of informations by electric means. Now, when you say information, it is something which is to be conveyed. The information must be transferred to a distant place. Now, the information may be a text message, or it may be a sound wave or audio signal, or it may be picture information or the video information. So, the information must be transferred to a distant place. The main communication, the important communication devices are the internet, the cell phones, TV, radio, pages, fax machines, etc. Now, let us study the block diagram of the basic electronic communication system. The main function of the communication system is to transfer the information. Now, there are 5 basic functional units of a communication system. One is the information source, and then the transmitter, the communication channel, the noise and the receiver. These are the important functional units of a communication system. We will discuss one by one. Let us observe the block diagram of a communication system. Now, here we have the information source. The information source originates the information. The information is originated from the information source. This information may be a picture, or it may be text message, or it may be a sound wave or audio information. Now, the information cannot be transmitted to a distant place directly. So, this information is converted into electrical signal with the help of the transmitter. The transmitter converts the information into an electrical signal. Say for example, if it is sound wave, the sound wave is converted into electrical signal with the help of the microphone. Microphone is a transducer which converts the sound wave into corresponding electrical signal, which is known as the audio signal. Now, if it is the picture information, the camera tube converts the picture information into electrical signal, which is known as the video signal. So, now transmitter converts the information into an electrical signal. The transmitter also performs several tasks. One is it processes the information so as to make it suitable for transmission over a given communication channel. In other words, the transmitter performs a function which is known as the modulation. In the process of modulation, the low frequency information signal is superimposed on a high frequency wave, which is known as the carrier wave. So, this process is called the modulation. So, transmitter not only converts the information into electrical signal, in addition to that it modulates the signal. So, modulation is the superimposing of the low frequency information signal on a high frequency carrier wave. Now, the transmitter also amplifies the signal. Moreover, the transmitter processes the information so that it can be transmitted over a given communication channel. Now, next is the communication channel. The communication channel is the medium by which electrical signals are transmitted from one place to another place. In other words, we can say that the communication channel is the link connecting the transmitter and the receiver. The different types of communication channels are, one is the optical fibers. In the case of optical fiber, the information is transmitted from one place to another place with the help of light waves. And another communication channel is the coaxial cable. The cable which connects the dish antenna and the set-top box is coaxial cable, or even you might have seen the cable networks which uses the coaxial cable. The coaxial cable is also one of the communication channel. We can use simply a pair of wire to transfer the information from one place to another place. And one more important communication channel is the free space. When free space can also be used as a communication channel, when telephone lines are also used as the communication channels. Now, what is communication channel? It is the medium by which electrical signals are transmitted from one place to another place. The different types of communication channels are the optical fiber, the pair of wires, the telephone lines, the free space, etc. The next is the noise. As the signal is transmitted from one place to another place, due to the presence of some disturbance in the communication channel, the information may be altered or it may be lost. This disturbance present in the communication channel is called the noise. Noise is something unwanted. In electrical sense, noise is defined as an unwanted form of energy tending to interfere with the easy reception and reproduction of the wanted signal. So, as the signal is transmitted from one place to another place, due to the introduction of some disturbance present in the communication channel, our information signal may be lost or it may be altered or it may be distorted. So, this unwanted form of energy which disturbs our transmission is called the noise. So, noise is an unwanted form of energy tending to interfere with the easy reception and reproduction of the wanted signal. The next is the receiver. Now, the receiver receives the signal from one of the communication channel. The receiver will receive the modulated wave, because before transmission we have modulated signal. Therefore, receiver will receive the modulated wave. It may receive the signal from through optical fiber channel, or it may receive through the coaxial cable, or it may receive from the free space, etc. So, receiver will receive the modulated wave from one of the communication channel. Now, the receiver will receive modulated wave, but it is not the information signal. Modulated wave carries information, but it is not the original information. Therefore, the receiver extracts the information from the modulated wave. The modulated wave contains the information. So, now receiver has to extract the information from the modulated wave. So, receiver performs a task which is known as the demodulation, or it is also called the detection. Now, demodulation is the process of recovering of the information signal from the modulated wave. The receiver also performs another task which is known as the amplification. Now, as the signal is transmitted from one place to another place, as the distance from the transmitter goes on increasing, the signal strength also goes on decreasing. So, as the distance from the transmitter increases, the signal strength goes on decreasing with increasing distance from the transmitter. Therefore, the receiver also consists of some amplifier circuits to compensate for the transmission losses. Finally, the the information reaches the receiver, reaches the destination. Now, we may receive the information in the form of audio signals or audio sound wave, or we may receive the information in the form of the video signal or the picture information. If it is picture information, the signal is then fed to the LCD, LED or the monitor, etc. if it is audio information, then the information is fed to the loudspeaker for original sound reproduction. So, it is all about the block diagram of the communication system. Now, let us define some important parameters of the communication system. One is the signal to noise ratio. The signal to noise ratio is one of the parameter which is used to check the power level of the signal, and it is also used to compare the power level of the signal with the noise power. Usually, the signal power should be greater than the noise power. If the signal power is less than the noise power, we can hear only the noise. So, this is one of the parameter which is used to check the power level of the signal at different points on the receiver. Now, what is signal to noise ratio? The signal to noise ratio is defined as the ratio of signal power to the noise power at the same point. So, signal power divided by noise power at the same point is called the signal to noise ratio. The next parameter, that is noise ratio. The noise ratio is used to compare the performance of different receivers. Now, noise ratio is defined as the ratio of signal to noise power at the input of the receiver or amplifier to the signal to noise ratio at the output of the receiver or amplifier. So, signal noise ratio is defined as the ratio of signal to noise ratio at the input to the signal to noise ratio at the output. That is, signal to noise ratio at the input divided by signal to noise ratio at the output is called the noise ratio. Now, the noise ratio is often expressed in decibel and is called the noise figure. Now, what is noise figure? The noise ratio expressed in decibel is called the noise figure. Noise figure is given by the formula 10 log to the base 10 NR in dB. 10 log to the base 10 noise ratio in decibel is called the noise figure. Yes, let us study the frequency of the radio waves. Usually in radio communication, after modulation, signal is fed to the antenna. When signal flows through the antenna, certain amount of power will be dissipated. Now, antenna radiates the waves in all directions. Now, the wave escaping from the antenna is called the electromagnetic wave. After modulation, the signal is fed to the transmitting antenna. Now, transmitting antenna radiates signals in all direction. The signal escaping from the antenna is called the electromagnetic waves. It is called the electromagnetic wave because it consists of both electric field and magnetic field components. These electric field and magnetic field components are perpendicular to each other and both are normal to the direction of propagation of the waves. Now, the electromagnetic waves consists of electric field and magnetic field components for spreading out in all directions. The electromagnetic waves propagate in earth atmosphere with the speed of light, that is 3 into 10 to the power 8 meter per second. These electromagnetic waves do not require any material medium for their propagations and their transverse waves. These electromagnetic waves exhibit all the properties of light such as reflection, refraction, interference, diffraction, etc. So, it exhibits all the properties of light. In addition to this, it also exhibits wave motion. It has some particle like property in addition to those associated with the wave motion, and then the electromagnetic waves consists of electric field and magnetic field components. Both are perpendicular to each other and normal to the direction of propagation of the wave. Now, the energy in the electric field and magnetic field components is equally divided between the electric field and magnetic field components. Now, the vacuum is the only perfect transparent medium for the propagation of the radio waves. It does not absorb energy. Almost all material medium absorb energy from some region of the entire electromagnetic spectrum. Now, you might observe the difference in the properties of these electromagnetic waves. Say for example, infrared radiation, it is not visible to the naked eye, but it has the same feature as that of the visible light. Just look at the difference between a visible light and infrared radiation. The infrared radiation is not visible, but only the visible radiations, VIBGYOR, colors are visible to the eyes. Now, there is a difference between frequencies of the visible spectrum and the infrared radiation. So, the difference in the properties of different electromagnetic waves are consequence of their different frequencies or wavelengths. So, as the frequency of the electromagnetic wave or the wavelength changes, their property also changes. Now, let us observe the electromagnetic wave. This is one of the diagram of electromagnetic wave. It consists of both electric field and magnetic field components. Just observe the direction. Electric field and magnetic field components are perpendicular to each other. Both are normal to the direction of propagation of the wave. Now, let us summarize the properties of the electromagnetic waves. The electromagnetic waves are transverse waves. They do not require a material medium for their propagation. The electromagnetic waves travel through free space with the speed of light 3 into 10 to the power 8 meter per second. The electromagnetic waves consist of electric field and magnetic field components for spreading out in all directions. The EM waves have wide range of frequencies or wavelength. The electromagnetic waves propagate in Earth atmosphere with the speed of light and it transports energy. Now, as the electromagnetic wave propagate in Earth atmosphere, the receiving antenna, one of the receiving antenna will receive the signal, right. Now, the main purpose of communication is to transfer the information. After modulation, signal is fed to the transmitting antenna. Now, the transmitting antenna radiates electromagnetic waves in all directions. Now, the electromagnetic wave consists of electric field and magnetic field components. Now, as the electromagnetic wave propagates in Earth atmosphere, the receiving antenna, there may be number of receiving antennas, these receiving antennas will receive the signal, right. The electromagnetic wave or the radio wave can take one or more different paths to reach the receiving antenna. Now, these important paths that the receiver can take, the electromagnetic wave can take are, one is called the ground waves or the surface waves, or the other one is called the sky waves or the ionospheric waves, and the last one is called the space waves or direct waves. Let us observe the spectrum of electromagnetic wave. It covers the entire electromagnetic spectrum. Now, initially, you just observe the low frequency region. Here, the lowest frequency, that is ELF, extremely low frequency signal. The frequency may be 30 hertz, very low frequency, 10 to the power 7 meters. And the next one is the VLF, very low frequency signal, around 3 kilohertz, very low frequency signal. The next is the low frequency signal, 30 kilohertz to 300 kilohertz. And then the medium frequency, 300 kilohertz to 3 megahertz. High frequency signal, 3 megahertz to 30 megahertz. Very high frequency signal, 30 megahertz to 300 megahertz. UHF or ultra high frequency, 300 megahertz to 3 gigahertz. And then SHF, super high frequency signal, 3 gigahertz to 30 gigahertz. And then extremely high frequency, 30 gigahertz to 300 gigahertz. And then we have the infrared radiations, the visible spectrum, and the X-rays and cosmic rays. We will now study the applications of these frequencies. On the top of the diagram, you can observe the wavelength of these electromagnetic waves. Let us study the applications of different frequencies and their applications. One is the very low frequency 3 kilohertz to 30 kilohertz. 3 kilohertz to 30 kilohertz, which is the very low frequency signal. It is used for long distance point to point communications. The next is the low frequency signal 30 kilohertz to 300 kilohertz. It is a low frequency signal. It is mainly used for the navigation purposes. The next is the medium frequency signal 300 kilohertz to 30 megahertz. 300 kilohertz to 3 megahertz. Now, these frequencies are used for radio transmission. Usually amplitude modulated radios use medium frequency band 300 kilohertz to 3 megahertz. It is also used for ships to shore communication. And then walkie-talkie, policemen use this walkie-talkie. Police walkie-talkie is another application of the medium frequency band. And then the high frequency signal 3 megahertz to 30 megahertz. These are called HF frequencies, high frequency signals. These frequencies are used for international broadcasting purposes. These frequencies are used to receive the radio waves from neighboring countries. And then the telephone lines also uses the same frequency, and then aviation systems use HF band. The next is the VHF band, very high frequency signals 30 megahertz to 300 megahertz. These are used for radar signal transmission, TV signal transmission, FM signal transmissions, etc. So, radar signals, TV signals and FM signals are transmitted with the help of VHF, very high frequency signals. The next is UHF, ultra high frequency signal 300 megahertz to 3 gigahertz. These frequencies are used for TV signal transmission, radar signal transmission and aviation systems. It is also used for to transmit the TV signals. The next is the SHF, super high frequency signal. The frequencies may be in the range of gigahertz, 3 gigahertz to 30 gigahertz. These frequencies are used for satellite communication and radar signal transmissions. For radar signal transmission and satellite communications, we use super high frequency signal. These days we receive the TV signals with the help of the dish antenna. Here the SHF signals are used, SHF frequency, super high frequencies are used 3 gigahertz to 30 gigahertz. And the last one is the EHF, extra high frequency signal. These extra high frequency signals are not used in practice. It is used only for experimental purposes. The EHF signals requires expensive circuits, and moreover it requires expensive towers to receive the signal. So, it is not used in practice. So, it is used only in research laboratories, only for experimental purposes. Let us study the different types of paths or different types of waves that we receive the signal with the help of this electromagnetic wave. The electromagnetic waves propagate in Earth atmosphere and transport energy. These electromagnetic waves may take one or more different paths to reach the receiving antenna. Now, these important paths that the electromagnetic wave can take are, one is called the ground wave, or this is also called the surface wave, and then the sky wave or the space waves. Now, what are ground waves? The ground waves, as the name indicates, it propagates along the surface of the earth. The ground waves propagate along the surface of the earth. So, this is also called the surface waves. As the electromagnetic wave is incident on the surface of the earth, it induces an EMF or it induces a current. Therefore, the ground wave loses its energy by absorption, or attenuation. So, usually ground waves are vertically polarized. As the wave propagates along the surface of Earth may absorb most of its energy. In order to prevent attenuation or absorption, the ground waves are vertically polarized. So, as the ground wave propagates along the surface of the Earth, Earth absorbs most of its energy. Moreover, attenuation or absorption increases with increase in frequency. As the transmitting frequency increases, the absorption also increases. So, this limits the propagation of the ground waves up to few megahertz only. Very low frequency signals can be transmitted very easily with the help of the ground waves, but high frequency signals get attenuated or absorbed by the Earth's surface. The frequencies up to 2 megahertz can be transmitted with the help of the ground waves or the surface waves. And another reason is, as the ground wave is incident on the surface of the Earth, the reflected ray bends slightly from the normal. Now, as the wavefront is incident on the surface of the Earth, the angle known as the angle of incidence, also known as the angle of tilt, this angle of tilt goes on increasing as the wavefront propagates along the surface of the Earth. If the wave is incident on the surface of the Earth several times, this angle of tilt goes on increasing. Now, what happens when angle of tilt increases? As angle of tilt increases, the absorption or attenuation increases. The field strength decreases as the wavefront propagates along the surface of the Earth. So, if the wave is incident on the surface of several times, angle of tilt goes on increasing, thereby reducing the field strength. So, this limits the propagation of the ground waves to certain distance only. It cannot be transmitted to long distance. The ground wave propagates certain distance and then it dies out. So, moreover we can transmit only low frequency signal, because high frequency signals get absorbed by the Earth surface. So, there are few limitations of ground wave. One is it cannot be transmitted to long distance, and moreover high frequency signals cannot be transmitted with the help of the ground waves. The next one, that is the sky wave, or it is also called the ionospheric wave. The sky wave are the waves that are radiated from the transmitting antenna with large angle of tilt with reference to the Earth. These sky waves enter up the region of the Earth atmosphere known as ionosphere and get reflected back to the Earth. The sky waves enter the region of the Earth atmosphere known as ionosphere and get reflected back to the Earth. Now, the propagation of the sky wave depends upon three important factors. One is the density of the ionospheric layer, and another is the angle of incidence, and another is the frequency of the radio wave. Now, the Earth atmosphere receives large amount of solar radiations in daytime. As the solar radiation is incident on the Earth atmosphere, the upper reaches of the Earth atmosphere consists of some gases. As the solar radiation is incident on these gas molecules, the gas molecules split themselves into gas ions. Now, whenever an atom gains an electron, it becomes negative ion. Whenever an atom loses an electron, it becomes a positive ion. So, upper reaches of the Earth atmosphere gets ionized as it receives solar radiations from the sun. So, as the solar radiation is incident on the surface of the Earth, the gas molecules split themselves into gas ions. The density of the ionospheric layer depends upon the amount of solar radiation that the Earth atmosphere receives from the sun. Now, at night, the density of the ionospheric layer decreases due to the recombination of gas ions into molecules. One of the advantage of this ionospheric layer is that it helps us to transmit the signal to a long distance. So, the sky wave, the propagation of the sky wave depends upon three important factors. One is the density of the ionospheric layer. As the density of the ionospheric layer increases, greater absorption. Continuous exchanging of energy takes place between the ionospheric layer and the electromagnetic wave. Part of the energy is absorbed by the ionospheric layer and part of the energy get reflected back to the earth. So, one important factor, that is density of the ionospheric layer. The next is the angle of incidence. If the angle of incidence is very less, then the signal may not be reflected back to that, it may escape from the earth atmosphere. Now, next is the frequency of the radio wave. The low frequency signals can be transmitted very easily with the help of the sky wave, because this low frequency signal get reflected back to the earth very easily compared to the high frequency signals. The high frequency signals find it very difficult to return reflected back to the earth. As the frequency of the radio is increased beyond a particular frequency known as the critical frequency, the ray will not be returned down to earth, it escapes from the earth atmosphere. So, frequency is also another important parameter. Very low frequency signals can be transmitted very easily compared to the higher frequencies. The frequency up to 30 megahertz can be transmitted with the help of the sky waves. So, let us summarize the propagation of sky waves. These sky waves enter the region of the earth atmosphere known as ionosphere and get reflected back to the earth. These are the waves enter the region of the earth atmosphere known as ionosphere and get reflected back to the earth. The propagation of the sky wave depends upon three important factors. One is the sky wave, one is the density of the ionospheric layer, the angle of incidence and frequency of the radio wave. Now, the frequencies up to 30 megahertz can be transmitted with the help of the sky wave. Now, how to transmit the frequencies above 30 megahertz? So, how to transmit very high frequency signals? Very high frequency signals can be transmitted with the help of what is known as the space waves or direct waves. This is also called the line of sight waves. These are the waves that reaches the receiver directly from the transmitter. These waves usually propagate in straight lines. The frequencies above 5 megahertz can be transmitted with the help of what is known as the space waves or the direct waves. The space waves are the waves that propagates only in straight line. The propagation of the space waves requires very good line of sight condition. If there is any huge building or huge hills, if there is any obstacle like huge buildings or the huge hills, then ray will not be received. You might observe these days a number of microwave antennas are installed. These microwave antennas are used to transmit the cell phone signals. The cell phone you might observe in the corner of your house. In some of the corner you might receive high signal strength and some other corner signal may be very weak. This is because of the obstacles. So, the propagation of the space wave requires very good line of sight condition. If there is no obstacle, you can receive good signal. Now, let us consider the applications of the space waves. The space waves are used for the transmission of TV signals, FM signals, FM broadcast radios use the space waves, and then the radar signal transmissions, etc. use the space waves. Observe the diagram of propagation of space waves. The space waves consists of two components. One is called the direct wave and another is called the earth reflected wave. The cell phone signal transmission, the TV signal transmissions and radar signal transmissions use only the direct waves. The FM signal transmission also uses the reflected wave or the earth reflected wave. So, in the case of the space wave, it reaches the receiver directly from the transmitter. If there is any obstacle like huge buildings or hills, the ray will not be received. instead it may be diffracted. Here there is a concept known as the optical horizon and the radio horizon. Now, you know how exactly the space wave propagates. The space wave propagates only in straight line. The maximum distance for the propagation of the space waves is called the optical horizon. In other words, you can say that it is the maximum distance visible to the naked eye. So, the space waves can propagate up to curvature of the earth. The maximum limit for the propagation of the space waves is called the optical horizon. So, the space waves can propagate up to the curvature of the earth. Let me consider a point where let me consider the maximum point where exactly the space wave is received. Let me consider this is the point where exactly the space wave is received. It is found that if there is an antenna beyond the curvature of the earth, it also receives the signal from the same transmitter. How is it possible? This is because if there is an antenna beyond the curvature of the earth, consider this is the receiving antenna beyond the curvature of the earth, it also receives from the same transmitter. This is because the receiving antenna which is beyond the curvature of the earth receives signal through the space wave. It may receive the signal through the space wave. One of the important property of the sky wave is that whenever the sky wave enters the ionospheric layer, it bends. So, which carries the ray beyond the optical horizon. So, if there is any antenna beyond the curvature of the earth, it receives a signal from the same transmitter. This is because it receives the sky wave. So, these sky waves enter the region of the earth atmosphere known as ionosphere and get reflected back to the earth. So, the maximum distance for the propagation of the sky waves is called the radio horizon. Radio horizon is the maximum distance for the propagation of the sky waves. Here there is a formula, there is a relationship between the radio horizon and the optical horizon. The radio horizon is equal to 4/3 of the optical horizon. Radio horizon equal to 4/3 of the optical horizon. Now, what is optical horizon? Optical horizon is the maximum distance for the propagation of the space waves, or you can say that it is a maximum distance visible to the naked eye. Now, what is radio horizon? The radio horizon is the maximum distance for the propagation of the sky waves. So, radio horizon is equal to 4/3 of the optical horizon. Let us study the theory of ionospheres. Ionosphere is one of the layer which is present on the upper layer of the earth atmosphere. Here the entire earth atmosphere is divided into 4 different layers. The layer which is just adjacent to the earth surface is called the tropospheric layer. It extends up to a height of 15 kilometers. The next layer is called the stratosphere layer. This layer consists of ozone which absorbs and scatters the ultraviolet radiation that it receives from the sun. The next is the mesosphere layer, exists at a height of approximately 50 kilometer to 85 kilometers. The last layer is called the ionospheric layer. It exists at a height of around 100 kilometers from the surface of the earth and extends up to 250 kilometers. Now, the entire earth atmosphere is divided into 4 layers. One is called the D layer, the next layer is called the E layer, and then the other 2 layers are called F1 and F2 layers. So, the entire earth atmosphere is divided into 4 different layers: D layer, the E layer, F1 layer and the F2 layer. The last 2 layers, F1 and F2 layers, exist in daytime. At night, these 2 layers recombine themselves to form a single layer which is called the F layer. So, F1 and F2 layers recombine at night to form a single F layer. Yes. consider the ionospheric layer. The ionospheric layer or the upper layer of the earth atmosphere receives large amount of solar radiations in daytime. The important ionizing agents are the alpha, beta and gamma radiations from the sun, the cosmic rays, ultraviolet radiations from the sun, etc. So, as the solar radiation is incident on the upper layer of the earth atmosphere, the gas molecules split themselves into gas ions. The density of the ionospheric layer depends upon the amount of solar radiation that the earth atmosphere receives from the sun. We will now study the different layers of the ionosphere, the D layer, E layer and the F layer. The layer which is just adjacent to the earth atmosphere is called the D layer. The D layer exists at a height of approximately 70 kilometers from the surface of the earth. Its average thickness is around 10 kilometers in daytime. The D layer exists only in daytime. At night it disappears at night. Now, the D layer is one of the important reflecting medium for very low frequency and low frequency waves. The very low frequency and low frequency waves get reflected back to earth from the D layer and it absorbs the MF and HF waves. It is one of the transparent medium for medium frequency and the high frequency waves. The next is the E layer. The E layer exists at a height of approximately 100 kilometers from the surface of the earth. Its average thickness is around 25 kilometers in daytime. This layer also exists only in daytime. At night it disappears. The disappearance is due to recombination of gas ions into gas molecules when solar radiation is no longer available. At night the gas ions recombine themselves to become gas molecules. So, therefore, the E layer disappears at night. The E layer is one of the reflecting medium for the very low frequency, the low frequency and medium frequency waves, and it partially reflects the HF waves. It is a transparent medium for most of the high frequency radio waves, but some of the high frequency radio waves get reflected from the E layer back to earth. The next is the F layer. The F layer begins from about approximately 150 kilometers from the surface of the earth and extends up to 400 kilometers from the surface of the earth. Now, the F layer exists at night. In daytime, the F layer splits into two layers which are called F1 layer and the F2 layers. The F1 layer, consider the F1 layer. The F1 layer exists at a height of approximately 200 kilometers from the surface of the earth. Its average thickness is around 20 kilometers in daytime. The F1 layer is also called the Kennelly Heaviside layer. The F1 layer is called Kennelly Heaviside layer. It exists at a height of 200 kilometers from the surface of the earth. Its average thickness is around 20 kilometers in daytime. At night it recombines with the F2 layer to form single F layer. The F1 layer partially reflects the high frequency waves. It is a transparent medium for most of the high frequency waves, but some of the high frequency waves get reflected from the F1 layer to the earth. The next is the F2 layer. The F2 layer exists at a height of approximately 300 kilometer to 400 kilometers or 300 kilometer to 600 kilometers in daytime. The F2 layer is one of the important reflecting medium for the propagation of high frequency waves are considered. The F2 layer, its height, the ionization density, everything keeps on varying time to time, day to day, month to month and year to year. It all depends upon the amount of solar radiation that the earth atmosphere receives from the sun. The F2 layer is also called the Appleton layer. Appleton is one of the scientists who invented this layer. So, it is also called the Appleton layer. The height and the thickness of the F2 layer keeps on changing, very difficult to predict the height and ionization density of the F2 layer. its approximate thickness is around 200 kilometers. The F2 layer is one of the important reflecting medium for high frequency waves. The high frequency waves get reflected back to earth from the F2 layer. The F2 layer recombines with the F1 layer at night to form the single F layer. The ionized density, the thickness keeps on changing time to time. So, one of the property of the F2 layer is that it changes its altitude seasonally. In the month of June, the earth atmosphere receives large amount of solar radiation. Therefore, in the month of June, the ionized density may be very high, thickness may be very high. In the month of December, the earth atmosphere receives less amount of solar radiation, so thickness may be less. So, the height and the thickness keeps on changing time to time. It all depends upon the amount of solar radiation that the earth atmosphere receives from the sun. Now, let us study some important parameters of the radio wave propagation. Now, the skywave propagation makes use of ionospheric layer as the important reflecting medium. The skywave propagation depends upon the frequency of the wave, the angle of incidence, the density of the ionospheric layer. As the radio wave is incident on the ionospheric layer, it undergoes both reflection and refraction. Now, the low frequency signals can be transmitted very easily compared to the high frequency signals. As the frequency of the radio wave is gradually increased, the ray will find it very difficult to get reflected back to the earth. This is a particular frequency called the critical frequency. If the transmitting frequency is increased beyond this critical frequency, the ray will not be returned down to earth, it escapes from the earth atmosphere. Now, what is critical frequency? The critical frequency is usually it is defined for a particular layer of the ionospheric layer. So, critical frequency for a given layer is the highest frequency of the beamed radio wave that will be returned to the earth. If the transmitting frequency is increased beyond the critical frequency, the ray will not be returned down to earth, it simply escapes from the earth atmosphere and hence the energy is wasted. So, let us define critical frequency. For a given layer, it is the highest frequency of the beamed radio wave that will be returned to the earth. Now, there is an angle known as the critical angle. If the angle of incidence is less than the critical angle, then the ray will not be returned down to earth, it escapes from the earth atmosphere. Now, critical layer is defined as, for a given layer, it is the maximum angle of incidence of the radio wave under ionospheric propagation that gets returned to the earth. For a given layer, it is the maximum angle of incidence of radio wave under ionospheric propagation that gets reflected back to the earth. If the angle of incidence is less than the critical angle, the ray will not be returned down to earth, it escapes from the earth atmosphere. The next definition, that is skip distance. Now, let us observe this diagram. Let me consider a transmitting antenna which radiates signals in all directions. Let me consider one of the ray which is incident on the ionospheric layer with large angle of incidence. You can observe that the ray 1 returned down to earth with large distance from the transmitter. Now, let me consider another ray, say for example ray 2. This ray 2 is incident on the ionospheric layer with an angle of incidence less than that for ray 1. Naturally, this ray returns down to earth with closer distance to the transmitter. We will now reduce the angle of incidence further. Let us consider the ray 3, which is incident on the ionospheric layer with an angle equal to the critical angle. Naturally, this ray returns down to earth with shortest distance from the transmitter. Now, this distance is called the skip distance. Now, what is skip distance? It is the distance between the transmitting antenna and the first skywave reception. It is the shortest distance or the minimum distance measured along the surface of the earth. It is the shortest distance measured along the surface of the earth at which a skywave of specified frequency can be propagated and returned reflected back to the earth. Now, ray 3 is the first skywave which is received. Ray 3 is the first skywave. Now, let us reduce the angle of incidence further. If angle of incidence is reduced further, as in the case of ray 4 and ray 5, the ray will not be returned down to earth, it simply escapes from the earth atmosphere and hence the energy is lost. So, it must be noted that we can transmit a signal only if the angle of incidence is greater than or equal to the critical angle. So, we will now define the skip distance first. It is the shortest distance measured between the transmitting antenna and the first receiving antenna measured along the surface of the earth after ionospheric propagation. Next is the next definition, that is skip zone, or it is also called the silent zone. It can be explained on the basis of this diagram. Now, observe this diagram. Here I am considering number of skywaves that are transmitted by this transmitting antenna. As you know, let me consider this point. This point is a point where exactly the first skywave is received. The skywave enters the region of the earth atmosphere known as ionosphere and get reflected back to earth. Let me consider a ray which is incident on the ionospheric layer with an angle equal to the critical angle. So, this ray returns down to earth with shortest distance from the transmitter. Now, let me consider the point where the first skywave is received. Now, consider the ground wave. The ground wave propagates along the surface of the earth. The ground waves can propagate certain distance and afterwards it dies out. It loses energy completely and dies out. Let me consider this point as the last point of ground wave reception, and this is the point of first skywave reception. Now, consider the region between the last point of ground wave reception and point of first skywave reception. This region is called the skip zone. This region neither receives the ground wave nor the sky wave. So, this region is called the skip zone. In a simpler words, you can say that it is a not reachable area. The signal will not be received. This region will not receive the signal from this transmitter. So, this region is called the skip zone, or also called the silent zone. It is a region around the receiving antenna within the skip distance. Neither the ground wave nor the sky wave is present. So, one more definition known as the single hope distance. Single hope distance is similar to the skip distance. It is the maximum distance between the transmitting antenna and the first receiving antenna measured along the surface of the earth after ionospheric propagation. So, I repeat, it is the distance between the maximum distance between the transmitting antenna to first receiving antenna measured along the surface of the earth after ionospheric propagation. So, next is the multiple hope transmission. Usually, the broadcast transmitters are situated near the seashore. There is a reason why we have to construct the broadcast transmitters near the seashore. The sea water or the salt water is one of the important reflecting medium. Whenever the sky wave or the radio wave is incident on good conducting surface like sea water or salt water, it may take another reflection back to the earth. It is another advantage of the sea water. Now, whenever the radio wave is incident on good conducting surface like salt water or sea water, it may take another reflection back to the earth, and signal can be transmitted to long distance with the help of this sea water, and is called the multiple hoop transmission. There is one more technique used to transmit the signal to a long distance. It can be explained on the basis of this diagram. Let me consider a transmitter, and let me consider two receiving points, point A, point B. Now, in order to transmit the signal to a long distance, we use the repeater stations, or it is also called the relay station. Let me consider point A as a repeater station or the relay station. The main function of this repeater station or the relay station is to amplify the signal, is to increase the signal strength. Now, let us consider the maximum distance that the sky wave propagates is from the transmitter is only point A. If we consider a transmitter, okay, let us consider this transmitter. From this transmitter, signal can propagate up to point A. It is a maximum distance if we consider as radio horizon. Now, from this point A, we cannot transmit we can transmit the signal to another point, say point B, by using some repeaters. The point A consists of some repeaters. The repeater station are actually the amplifier. The repeater will receive the signal from the transmitter and it will increase the signal strength. It amplifies the signal and retransmit the signal back to the ionosphere. If we use number of such repeater stations or relay stations, signal can be transmitted to any distance. This is called multiple hoop transmission. The multiple hoop transmission uses repeater stations or relay stations to transmit signal to a long distance. Consider the point A receives the signal from the transmitter. The receiver will amplify the signal, it increases the signal strength and it retransmits the signal back to the ionospheric layer. Now, the receiver B will receive the signal from the transmitter, but it will not receive signal directly from the transmitter, it receives with the signal with the help of the repeater station situated at point A. So, with the help of these repeater stations, we can transmit signal to long distance, which is called multiple hoop transmission. Here there exists a concept known as the signal fading. Signal fading is nothing but the fluctuation in the signal strength at the receiver. Now, the receiver will receive signal from different paths or different hopes. You consider the receiving antenna. The receiving antenna will receive signal from the space wave or ground wave, or it may receive the signal through the sky wave. Whenever these signals arrive at the receiver simultaneously, it undergoes what is known as the signal fading. The fluctuation in the signal strength at the receiver is called the signal fading. The different types of signal fading are, one is the interference fading. Whenever the sky waves arriving at different layers of the ionosphere undergoes interference, there exists what is known as the interference fading. There is one more type of fading known as the polarization fading. Whenever the sky wave enters the earth atmosphere, it undergoes polarization. The electromagnetic wave splits into two rays called ordinary ray and extraordinary ray. These ordinary ray and extraordinary rays are perpendicular to each other. When these rays arrive at the receiver simultaneously, it undergoes polarization fading. The other types of fading are, one is the absorption fading, the skip fading, Rayleigh fading, Ricean fading, Nakagami fading, Weibull fading, selective fading, etc. These are the different types of signal fading. So, what is signal fading? It is the fluctuation in the signal strength at the receiver. That's all about the wireless communication chapter. Let me give you some important questions from this chapter. Before that, let us discuss the question paper pattern of this chapter. The maximum marks allotted for wireless communication chapter is only 3 marks. Students, note down this, only 3 marks. It may be one mark question and one 2 mark question, or it may be a single 3 mark question. You cannot expect any essay type questions from this chapter. So, maximum marks allotted is only 3 marks, one 1 mark question, one 2 mark question. So, total 3 marks, or it may be a single 3 mark questions. Let me discuss some of the important questions from this chapter. Students, note that you can expect maximum 1 mark questions and 2 mark questions, not more than that. So, the first question, how are the ground waves polarized? The ground waves are vertically polarized. Name any 2 paths that radio signal can take through space. So, one is sky wave, another is the space wave. What is ionosphere? That we have discussed. Which layer of the ionosphere has the greatest effect on radio signal, that is F2 layer? Which is the type of radio wave that propagates only over line of sight distance? That is the answer is space wave. What is fading? Already we have discussed. Signal fading is the fluctuation in the signal strength at the receiver. Define noise. Noise is defined as an unwanted form of energy tending to interfere with the easy reception and reproduction of the wanted signal. Define signal to noise ratio. It is defined as ratio of signal power to the noise power. Define noise ratio. It is defined as the ratio of signal to noise power at the input to the signal to noise ratio at the output. Define skip distance. Define skip zone, define critical angle, define critical frequency, define noise figure, define single hoop distance. These are the important definitions that you can expect in the annual exam. Let us discuss the 2 mark questions. Draw the labeled block diagram of communication system. It is one of the most important question under 2 marks. Very important block diagram. Already we have discussed the block diagram of communication system. The important units of communication system are the information source, the transmitter, communication channel, noise and receiver. Need to draw the block diagram. Mention the different types of radio wave propagation. There are 3 types of radio propagation: the sky wave propagation, the ground wave propagation and space wave propagation. Mention the layers of ionosphere: D layer, E layer, F1 layer and F2 layer. Next, the 3 mark questions. Explain in brief the ground wave propagation. Next, with the relevant diagrams, explain the ionospheric propagation. The last question, explain the concept of space wave propagation. So, let us summarize this chapter. In this chapter, you can expect 1 mark questions and 2 mark questions. So, mainly concentrate on 1 marks and 2 mark questions. You cannot expect any essay type questions. So, maximum marks allotted for this chapter is only 3 marks. That is all. Thank you.